Good morning.
Good morning.
Let's see, is anyone in Joseph City? Okay.
Good morning.
Good morning. Caden, is Miss Buckley there?
No, not yet.
Do you know how to change the camera?
Yeah, I'll do it.
Okay, thank you. All right, so Jordan, I thought you were going to be gone today.
Yeah, but not until they call us out of class.
Oh, okay. All right, very good. Well, we'll try to teach you everything that you need to know before you leave. So, I don't know. All right, let's see. So, there's Rex. Okay, let's see. Who are we missing in Winslow?
Brooke, Taylor, Shandon, and Junior.
Okay. Let's see. What's Junior's first name?
Junior. Junior Lee.
Oh, Junior Lee. That's what I don't know what I just couldn't see it. So, all right. Thank you. Okay. So let's see. So today we're going to finish up 11.2 and start in on 11.3. Does anyone have any questions before we get started? Well, or I guess I could ask, is anybody doing anything amazing this weekend?
Yeah, just Easter and stuff.
Easter? Are you going to dye some eggs?
Yep.
You're going to hide them for your little cousins to hunt?
Yeah.
All right. That sounds like fun. Although I heard a thing that said that if you use real eggs, then you need to eat them within like 2 hours of taking them out of the fridge. Because I remember when I was a kid, we used to use real eggs and we just hit them all day long. We would just hunt them and hide them and play games with them. And then at the end of the day, after they've been out in the sun for like 8 hours, then we'd eat them. So they say that's not a smart thing. So anyway, anybody else do anything fun?
What are you doing this weekend?
Well, Easter and stuff, and I've got to go to Snowflake, but I am going to be actually preaching an Easter sermon on Sunday. If you're all invited, if you want to come to Joseph City at 11:30, anyway, you can see if I preach as good as I teach, or better, or worse, or something. Anyway. So that's kind of fun, just to do that every once in a while. So, but you're all invited if you'd like to come. Well, let's go ahead and get started. Thanks for asking. So today we were left off on practice 2C, and I had asked you to work that problem before class today. So let's see if, let's take a look at this. All right. So it says, find a formula for the nth term of the arithmetic sequence. The 8th term is 25 and the 12th term is 41. All right. So the first thing you need to do here is, in fact, figure out what D is. All right. So did anyone figure out what D is? All right. Well, let's go through the process to explain how you find D. So you say, all right, the eighth term is 25. The 12th term is 41. So then to go from the eighth term to the 12th term, you're going to have to add in D 4 times. Okay. So then you say, all right, so a sub 12 is a sub 8 plus 4D. And then you plug in what you're given for a sub 8 and a sub 12. And then you solve that for D. So subtract 25 and then divide by 4. And so you get D is 4. Okay? All right. So the next step is to find a sub 1. All right, can anyone tell me how you find a sub 1, or if you found a sub 1, what it is? How do you go about doing it? Well, we're trying to find a sub 1. We do know a sub 8 is 25. So how many D's would you have to add to get from a sub 1 to a sub 8?
8.
7.
7.
Because you start with 1. So to go from the first term to the eighth term, you'd have to add it 7 times. So what you do is you say, all right, a sub 8 is a sub 1 plus 7D. Okay? And so 25 is a sub 1 plus 28. Subtract, and you get a sub 1 is negative 3. All right? So now we have a sub 1 is negative 3. We have D is 4. So now you can actually plug it into this equation that we used yesterday. Not this one. This one right here. Okay? All right, so plug that in, your a sub 1 and your D, to get the final answer. The formula for a sub n. All right, so Alana, when you've got it.
4n minus 7.
4n minus 7, okay. So a sub n, sorry. So a sub n equals 4n minus 7. Good job. So this part here in green would do it. Actually, let's make this green too. Okay, any questions on any of that? Okay. Okay, so good. All right, now let's look at this next problem. It says a drama student wants to know if there is a formula for the seating of an auditorium. It has 30 rows of 20 seats, 20 seats in the first row, 22 seats in the second row, 24 seats in the third row, and so on. Okay. So is there a formula that would for the seating that would tell us how many seats? Okay. So is this scenario here an arithmetic sequence?
Yes.
Yes. And so what would be your D?
2.
2. And what's your A sub 1?
20.
20, because it says there's 20 seats in the first row. So if you put it into that formula, and you've got D is 2, and A sub 1 is 20. So go ahead and put it in there, and then simplify the formula. All right, come on. It keeps picking people that aren't here. Oh, that's funny. All right, there we go. All right, so Cameron, when you've got it.
A sub n equals 2n plus 18.
So A sub n equals 2n plus 18. Very good. So, so let's say we wanted to know how many seats are in the 10th row. Then what would we do?
Plug in 10.
Plug in 10 for n. So then you'd have A sub 10 would be 2 times 10 plus 18. So that would mean there's 38 seats in the 10th row. Okay? So that would be kind of nice to, be able to do. Right? So any questions on that one?
No questions, but Shandon's here now.
Oh, okay. Okay. Thank you. All right. So okay, so okay, so this is the formula actually there's two formulas here. And I kind of want you to write them down. The sum of the first n terms of an infinite sequence or a finite sequence is S sub n equals n divided by 2 times A sub 1 plus A sub n. So that's the formula you use if you know the last term. Okay? If you don't know the last term, then you can use this formula. S sub n equals n divided by 2 times 2A sub 1 plus n minus 1 times d. That's if you don't know the last term. So this is actually the sum of a finite arithmetic sequence, or if it's an infinite sequence but you're only doing a partial sum. That's what we mean by that. It's the same formulas. Okay? So it's kind of like if I say, here are these 10 terms, add them up. Or if I say, okay, there's a infinite number of terms, but we're only adding the first 10, then it's still considered like a finite sum. Okay? So, again, if you know the last term, you use this one. If you don't know the last term, you use this one. Okay? All right, so the sum of the first n terms of an infinite sequence is called the partial sum. So it can be found by using the formula for the sum of a finite arithmetic sequence. So then here's the formulas again. Okay? Maybe I should put that slide before the last slide, so you know what to write down. Okay. Okay, so let's look at some examples here. All right, so it says find the sum of the first n terms of the arithmetic sequence. So here's the sequence: negative 31, negative 8, 15, 31, 61, dot, dot, dot. But then here, so here it looks like it goes on forever. But then it says n equals 20. So that means we're adding up the first 20 terms. Okay? Now, do we know the 20th term? No, we could calculate it, but right now we don't know. And so it's better to use it's better to use the first formula. This one, when you don't know the last term. Okay? Let's see. Okay. So this is the formula I'm going to use because I don't know the last term. Okay, so S sub n, that means just the sum of the first 20 terms. So we'll do S sub 20. So n is the number of terms. So we do 20 divided by 2 times 2 times the first term. So the first term is negative 31. The n is 20 again. Now the d we get by just subtracting any two terms. So if we take negative 8 minus a negative 31, that's going to be 23. So our d is 23, our a sub 1 is negative 31, and our n is 20. So now I plug it into the formula, and I get s sub, let's go ahead and write s sub 20 here. So S sub 20, so the sum of the first 20 numbers is 20 divided by 2 times 2 times a sub 1, negative 31, plus n 20 minus 1 times d, which is 23. And so now you can just put it in the calculator if you want, or just simplify it. 20 divided by 2 is 10. 2 times negative 31 is negative 62. And then 19 times 23, 437. You add and multiply, and so the answer is 3,750. Okay? All right, any questions on that? All right, so go ahead and try practice 3A, please. All right, so Dominic, when you've got it.
$10,100.
All right, let's see. 10,000. Oh, I got 4,600. 4,600. All right, so let's see. So it says the first 50 terms. So n is 50. The first term is -6, and then you're adding 4 each time. So your d is 4. All right, so your s of 50 would be 50 divided by 2 times 2 times the first term. A sub 1 is -6, plus 50 minus 1 times d, which is 4. So 50 divided by 2 is 25. 2 times -6 is -12.
Mr. Strong,
Yes.
for paper, it's 6, -2, 2, 6.
The negative's like on a sentence above it.
Okay. 6, -6.
Yeah, the negative
Oh.
should be right up there.
Okay, it's a bad print job because see, the negative is above in the previous line, so it just didn't carry over. So I'll need to fix that. Do you see the negative after the word sequence?
Yeah, after the word sequence.
Yeah. So that's stuff like that drives me crazy when I was a student, and if you miss a question on a test because of it's not technically a typo, it's just a formatting error. So anyway, so yeah, okay, yeah, that would cause you to miss it right there. Okay. All right. We'll do another one here in just a minute. But any questions on the setup?
No.
Okay. All right. Well, let's look at another one here. Okay. Okay. So let's look at this. This is actually the same auditorium problem that we did a minute ago, where we found a formula for the number of seats in each row. Now we're going back and we're actually wanting to determine the seating capacity, or the total number of seats, okay, in this auditorium. So still, we have 30 rows of seats, and there are 20 seats in the first row, 22 seats in the second row, 24 seats in the third row, and so on. All right, so see if you can apply that same formula to this situation to get the total number of seats this time. All right. So, Andrew, when you've got it.
1,470.
1,470 is correct. Beautiful. Any questions on that? Anyone like me to go through it? All right. So great job. See, that's a lot easier if you start seeing patterns. That's a lot easier than going into your auditorium and just counting all the seats. But it's amazing to me that you still see people do that don't use the patterns to help them make shortcuts and be able to do a calculation like that. Okay. All right. So now let's talk about the other formula. Okay, it says the sum of a finite arithmetic sequence with n terms is given by, so this is the other one, S sub n equals n divided by 2 times a sub 1 plus a sub n. So you use this when you do know the last term, okay? But the formula only works with arithmetic sequences. Okay, now this formula actually has a story to it. Okay, there was a little boy in the 3rd grade. His name was Carl, and so Carl was really good at math. And I don't know if you remember in the 3rd grade, but a lot of times if you're really good at math or you're really good at whatever, you know, your teacher gives you an assignment or a worksheet or whatever, and you finish it way before all the other kids do, then what does the teacher do usually? If you finish in the 3rd grade, what does the teacher do if you finish work ahead of time?
Help the other kids?
They what?
Help the other kids?
Okay, some teachers will have you help the other kids, and I think that is a good teacher. Unfortunately, a lot of teachers, what they do, if you finish early, then your reward is you get another worksheet. You get more busy work. Any of you ever remember that happening? Where you just get more work? Well, so that's what happened to Carl. He was finished way ahead of all the other kids. So his teacher said, you know, she's trying to maintain, do the classroom management. So she tells Carl, Carl, I want you to go back to your seat, and I want you to add up all the numbers between 1 and 100. Okay, that's like the ultimate busy work. Right? You're just adding up the numbers 1 to 100 just because. Well, so Carl started walking to his seat. He turns around and he comes back up to the teacher's desk. And the teacher says, Carl, I don't think you understood. I want you to add up the numbers from 1 to 100. And Carl says, I've got the answer. And she says, there's no way. And he says, the answer is 5,050. And she's like, anyway, she didn't believe him. So after the kids finish and they go to recess or whatever, she's like working all through recess. She's adding up all these numbers, and guess what answer she gets? 5,050. And so she's just blown away. And she's like, Carl, how did you do that? All right. So basically what Carl did is he kind of thought of in terms of the patterns. Is he thought, okay, the number 100 is kind of like by itself. But all the other numbers I can add up in pairs. So like 1 and 99, 2 and 98, 3 and 97. So how many pairs adding up to 100 would he have?
50.
50. And then what one number wouldn't have a pair?
50.
The number 50. So he thought 50 times 100 is 5,000 plus 50. And so that's what he got. Right? And so Carl, anyway, just kind of another thing about him. So when he's in elementary school, his dad was an accountant, right? And his dad would bring home the books and have Carl check his figures. And so Carl would actually sometimes find mistakes in his father's computations and stuff. Anyway, I love that story. But Carl became a famous mathematician, Carl Friedrich Gauss. You might remember like the Gaussian method to do matrices, and we've talked about that in the last section or in your Algebra 2 class. Several things that you learn in high school are because of Carl. Well, this formula, then he later came up with this formula that would do the same thing. See, like if I said, add up the numbers. Well, let's go back to using this sequence. See what Carl did is he said, okay, using this formula. See, he could have said the sum of the first 100 numbers is 100 divided by 2 times the first number is 1 plus 100. So that's 50 times 101, which is 5,050. And so it works. Okay? So, but it could work with any arithmetic series, any sequence that we want to add up. Okay? So like here, if I say, find the sum of 1 plus 3 plus 5 plus 7 plus 9 all the way to 19. Now you could actually do it just by hand, but if you notice the pattern and you say, okay, the common difference is 2. We have, excuse me. So we have 10 numbers. So 10 divided by 2 times the first number is 1, the last number is 19. So we just crank that out. We can do it in our head there. 20 times 5, so we get 100. Okay? So that's a cool way of adding up an arithmetic sequence. All right? So see if you can do practice 3C. And try to use the formula. Don't just like add them up. All right, so Alana, when you've got it.
$217.
All right. So 217. Great job. All right, any questions on that? All right, now go ahead and try practice 3D, the last one there, using the same formula. All right, so Shannon, when you've got it.
630.
630 is correct. Great job. Any questions on that one? Now, so again, this is a type of problem that I've seen on ACT tests. And as I'm prepping students for it, you know, we'll do practice tests and one like this. And there's always one kid that will actually write down all the numbers, 1 through 35, and then just start putting them in the calculator or whatever. Meanwhile, you know, the person next to him that knows this has, you know, done the next 3 problems. Okay? So, anyway. All right, so that's 11-2 on arithmetic sequences and series. Now, 11-3, we want to just kind of introduce it a little bit. This is on geometric sequences and series. And so this is going to feel a lot like 11-2, but it's just a different type of sequence or series. Does anyone know what a geometric sequence is? Okay, let's see if I can ask a leading question. Okay, if an arithmetic sequence is where you add the same number each time to get the next number, a geometric sequence is where you multiply. Okay, you multiply by the same number each time. So where an arithmetic sequence is like 2, 4, 6, 8, you're adding 2. A geometric sequence would be like 2, 4, 8, 16, 32, where you're multiplying by 2 each time, or whatever. Okay? So, the number that you multiply by each time in a geometric sequence is called the common ratio, R. So, just like to find the D, the common difference, you would subtract. If you divide any 2 consecutive numbers, you should get the same number each time. And that number that you get is R, or the common ratio, as it's called. Okay, so to figure out if a sequence is geometric, what you do is just divide. So you take 2, 4 divided by 2 is 2. So when we divide any 2 consecutive numbers, we should get 2. 8 divided by 4 is 2. 16 divided by 8 is 2. So since we get 2 each time, this is geometric and the R is 2. Okay? So, see if you could do practice 1A. All right, so Lana again. Is this sequence geometric?
Yeah.
And what's the R?
3.
3. Because 6 times 3 is 18. 18 times 3 is 54, and so on. So it is geometric. The R is 3. Good job. Any questions on that? Okay, so here's a sequence 1, 4, 9, 16. Now, you might recognize a pattern, but if you do 4 divided by 1, you get 4. But then 9 divided by 4 is not 4. So as soon as that happens where you don't get the same thing, then it's not geometric. Okay? All right. So now do practice 1B. Give me an example of a series. Whoops. So you give me an example of a series that's not geometric. 'All right, Alana, you're going to win the lottery someday. All right, so Alana, give me a series that's not geometric.
3, 6, 12, 36.
3, 6, 12, 36. All right, let's see. So 6 divided by 3 is 2. All right, 12 divided by 6 is 2. So far it's geometric. But 36 divided by 12 is 3. So that messes it up. So this is not geometric. So that's a good example. For a minute, though, I was a little worried, but you got it, okay? Any questions on that? Okay, good. That's funny. Okay, so now finding terms of the geometric sequence. So every term, or the nth term, I guess I worded it a little bit differently on this. Let's see, the nth term. Every geometric sequence can be written in the form, let's see, why? A sub n. I guess the first blank should be a sub 1, a sub 1 times r, a sub 1 times r squared, a sub 1 times r cubed, dot, dot, dot. So the formula has the form a sub n equals a sub 1 times r to the n minus 1. Now, why is it to the n minus 1 and not n? Well, because the first number, you don't multiply by r. It's just after the first term, then you start multiplying by r. So that's why it's n minus 1, where r is the common ratio. Okay? All right. So, to find the formula for a geometric sequence, you should first find r, the common ratio, by dividing any two consecutive terms. With this formula, you can find any term of the geometric sequence, provided you know a sub 1, or the first term. So if you know the first term and the r, you can find anything. Okay? So as we look at this, again, the first thing we want to find here is r. So if we take 1/9 divided by a third. So 1/9 divided by a third, that's the same as 1/9 times 3. So the r is 1/3. That simplifies to 1/3. So we're multiplying by a third each time. All right, and we know our a sub 1. So then our formula is a sub 1 equals the first term, which is 1/3, times r, which also happens to be 1/3. They don't have to be the same number, but they could be. So a sub 1 times r to the n minus 1. All right, so see if you can do practice 1 or practice 2a. All right, so Kaden, what do you have? Or when you get it?
I got 1/2 times 1/2 raised to the n minus 1.
That's it. Good job. So the r is 1/2, because if you take 1/4 divided by a half, you get 1/2. And then a sub 1 is also 1/2. So a sub n would be 1/2 times 1/2 to the n minus 1. All right, great job. All right, any questions on that? So if we are given r and another term, not a sub 1, we can use the formula to find a sub 1, because we need a sub 1 for the formula. So if we don't have a sub 1, we've got to find a sub 1. All right, so let's see. So let's say a sub 2 is -6. A sub 5 is 162. So we need to find r and a sub 1 so that we can use the formula. So you say, well, how many times do you have to multiply r by to go from the second term to the fifth term? 3, because 5 minus 2. So then a sub 5 would be a sub 2 times r cubed. So now we plug in and we say 162 is -6 times r cubed. Divide each side by -6. Take the cube root. And r is -3. So now once we have r, then now we can figure out what the a sub 1 is. So we say a sub 1 is, all right, now a sub 2 was -6. So if we divide by the -3, then we'll get a sub 1. So to go from a sub 1 to a sub 2, you multiply by r. To go backwards, you would divide by r. So -6 divided by -3 is 2. Okay, so now we have a sub 1 and we have r, so now we can write the formula. So a sub n equals 2 times -3 to the n minus 1. All right, so go ahead and try practice 2B. All right, so Andrew, when you've got R, tell us what you get for R.
Negative 1/3.
Negative 1/3. Yep. Okay. Anyone like me to go through how we got that?
Yes, please.
Okay. So you're given a sub 2 and a sub 5. All right, so we're down to our last minute. So I want you to try to finish this problem for Monday if we don't finish it. But here we want to go from a sub 2 to a sub 5. We've got to multiply by r 3 times. So you say a sub 5 equals a sub 2 times r cubed. So 2/3 equals negative 18 times r cubed. Divide both sides by negative 18. So here I did 2/3 divided by negative 18, and I got negative 1/27. And now take the cube root. And so when you're taking the